December 18, 2025. Less than 24 hours before interstellar comet 3I/ATLS would make its closest approach to Earth, the Breakthrough Listen team pointed the world's largest steerable radio telescope at it. They weren't looking for water, not ice, not dust. They were looking for technosignatures, artificial radio signals, narrowband transmissions, something that could indicate a technological civilization. Why? Because in all of human history, we've detected only 3 interstellar objects, 3, and one of them, Oumuamua, behaved so strangely that some scientists are still debating its nature. So, when the third visitor from interstellar space passes within 167 million miles of Earth, you check, just in case. What did they find? Let's break down the facts. July 1, 2025. The ATLAS system, Asteroid Terrestrial Impact Last Alert System, detected an object moving through the solar system on an escape trajectory. Orbit hyperbolic. Velocity relative to the Sun over 30 kilometers per second. This isn't our object. Calculations confirmed 3I/ATLS came from a different part of the galaxy, the third confirmed interstellar visitor after Oumuamua and Borisov. But unlike the first two, this object quickly showed classic cometary behavior: bright coma, long tail, signs of water ice sublimation. An ordinary comet, just interstellar. Age? Possibly older than our solar system. Some estimates suggest up to 7 billion years old. It may not have had close encounters with other stars for at least 10 million years. Imagine an object older than Earth crossing the galaxy alone until it accidentally wandered into the Sun's gravitational field. Because the previous interstellar object, Oumuamua, accelerated in a way that couldn't be fully explained by ordinary ice sublimation, Harvard astrophysicist Avi Loeb suggested it could be a probe. Most astronomers disagree, but the debate continues to this day.
The problem is we have too little data. 3 objects in all of observational history. That's statistically nothing. We don't know how rare interstellar visitors are, and we don't know what percentage of them might be artificial. Probability? Extremely low, but not 0. And here's the logic of Breakthrough Listen. If there's even the slightest chance that an interstellar probe exists and might use narrowband radio signals for communication, just like all our spacecraft do, including Voyager 1 and Voyager 2, then when such an object passes close enough, you need to check it. Not because they expected to find anything, but because it's a scientifically valid possibility that can't be ignored. December 18, 2025. Less than 24 hours before closest approach to Earth, the Breakthrough Listen team pointed the 100-meter Green Bank telescope at 3I/ATLAS, the world's largest steerable single-dish radio telescope. Frequency range 1 to 12 gigahertz. 4 receivers, L, S, C, and X band. Sensitivity: capable of detecting a transmitter with an effective isotropic radiated power of just 0.1 watts at a distance of 1.7 astronomical units. This is more sensitive than any previous observations of this object. The Meerkat telescope in South Africa and the Allen telescope array were also used for backup observations. Observation mode: ABACA, alternating on-source and off-source scans to filter out terrestrial interference. Total integration time: several hours across different frequencies. 9 events. 9 narrowband signals that looked promising at first glance. The team manually checked every single one. Result: all 9 were ruled out. Reasons: signals appeared in scans off the comet's direction. They matched known radio frequency interference bands.
All 9 were terrestrial RFI, radio frequency interference. In the preprint published December 19 on Archive, the team writes clearly and unambiguously, "We find no credible detections of narrowband radio technosignatures originating from 3I/Atlas." 2 other studies, one from the team of S.Z. Sheikh and another from D.J. Pisano, checked different frequency ranges with varying sensitivity. Same result, nothing. Simultaneously with the technosignature search, another team was investigating the non-gravitational acceleration of 3I/Atlas. Sounds like evidence of an artificial engine? No, it's normal for comets. When comets approach the Sun, volatile ices sublimate, ejecting gas and dust. Asymmetry in this process creates a rocket thrust that slightly accelerates the comet's nucleus. By measuring this acceleration and comparing it with mass loss estimates, you can determine the nucleus size.
Using data from ground-based telescopes, Mars orbiters, and spacecraft en route to Jupiter, the team calculated the diameter of 3I/Atlas's nucleus, about 1 kilometer. More precisely, between 820 and 1,050 meters, depending on density and outgassing asymmetry coefficient. Completely consistent with ordinary solar system comets. So what do we know? 3I/Atlas is behaving like a natural comet. No artificial signals. Size and acceleration match ordinary ice sublimation models. Almost certainly just an ancient chunk of ice from another solar system. But here's what matters. They checked. The world's largest SETI program pointed the best radio telescopes at an interstellar object at its closest approach, just in case. Because we have only 3 known visitors, and the possibility that one day one of them might not be natural, though small, exists. As the Breakthrough Listen team writes, given the small number of such objects and the plausibility of interstellar probes as a technosignature, thorough study is warranted. 3I/ATLS is now leaving the inner solar system. It will pass Jupiter, exit beyond the Oort cloud, and return to interstellar space. We may never see it again, but the next interstellar object might be different. The Breakthrough Listen observation data is publicly available. Anyone can download and analyze it. Both scientific papers are published on Archive and awaiting peer review. If you've been following this series on 3I/Atlas, from brightness pulsations to ice volcanoes to the final search for technosignatures, thank you for watching. Hit like if you want more content on interstellar anomalies that look natural but still make us think. Subscribe and turn on notifications. The next visitor might arrive sooner than we think. What do you think? Should we check every interstellar object for technosignatures? Let me know in the comments. Links to the preprints and Breakthrough Listen statement are in the description. See you in the next cosmic mystery.